Hi boys and girls, today we are going to go into lesson 2 of topic 11. So we are going to be decomposing fractions. Remember, decomposing means to break apart. We are on page 563, and let me go ahead and get started with the video.
How can you decompose a fraction in a variety of ways? Let's find out.
How can you decompose a fraction in a variety of ways?
Decomposing means to break into parts. Charlene has her garden separated into
parts.
She wants to leave 1/6 of it empty.
Charlene has her garden
What are some different ways she can plant the rest of her garden?
She wants to leave 1/6 of it empty. What are some different ways she can plant the rest of her garden?
The fraction of the garden that Charlene will plant can be broken apart in more than one way.
I can think of many different ways.
Charlene will plant can be broken apart in more than one way.
The garden is divided into 6 equal parts. Each equal part is 1/6 of the whole.
The garden is divided into
What are some ways that Charlene can plant her garden?
Each equal part is 1/6 of the whole. What are some ways that Charlene can plant her garden?
4 of the 6 sections are planted with blue flowers. You can show this with the fraction
4 of the 6 sections are planted with blue flowers.
One of the 6 sections is planted with red peppers.
4/6.
This is shown with the fraction 1/6.
One of the 6 sections is planted with red peppers.
Altogether, 5/6 of the garden is planted.
1/6.
5/6 is 4/6
Altogether,
and 1/6.
5/6 of the garden is planted.
The picture shows that 5/6 of the garden can be broken apart into 4/6 and 1/6.
The picture shows
What's another way to break
5/6
apart
of the garden
5/6
can be broken
if Charlene
apart
planted
into
her garden
4/6
differently?
And 1/6. What's another way to break apart 5/6 if Charlene planted her garden differently?
Four of the 5 filled sections are blue flowers.
To see which parts of the gardens they represent.
One of the 5 filled sections is red peppers.
Are blue flowers.
5 of the 6 sections are filled.
One of the 5 filled sections is red peppers. 5 of the 6 sections are filled.
Charlene could plant 5/6 of her garden in another way. She could also plant 1 section each of green beans, yellow squash, and red peppers, and 2 sections of blue flowers.
Each of green beans, yellow squash, and red peppers.
5/6 is 1/6 and 1/6 and 1/6 and 2/6.
5/6 is 1/6.
Describe how the expression represents the parts of the garden that are planted.
Describe how the expression represents the parts of the garden that are planted.
So we can also show 5/6 in a different way. If you notice on the video before, it was 4 out of 6.
One of the 5 filled sections is green beans.
Out of 6, that made 5.
One of the 5 filled sections is yellow squash. One of the 5 filled sections is red peppers. 2 of the 5 filled sections are blue flowers.
1 of the 5 filled sections is red peppers. 2 of the
5
filled
of the 6 sections are
blue
filled.
flowers.
Notice that the total is still the same.
5 of the 6 sections are filled.
The
It was
fraction
just
of the
filled
garden
in a
Charlene
different
will
way.
plant can be broken apart in more than one way. You can decompose a
The
fraction in
of the
more than
garden
one way.
Charlene will plant can be broken apart in more than one way. You can decompose a fraction in more than one way.
Okay, so we're now going to go into our math book, and we are going to turn to page 565. We're going to go ahead and start by first looking at question 1 and 2. Question 1 and 2 says, in 1 and 2, write each fraction or mixed number as a sum of fractions in 2 different ways. So if you notice, the fraction is the same, but they want me to show it in 2 different ways. So the first one says 3 out of 5. How can we break that apart? Well, we can say 2/5 plus 1/5. Remember that the denominator stays the same. The only thing I'm breaking apart is the 3, and I broke it apart into 2 and 1. So now we're going to decompose the same fraction, but notice that now we have 3 numerators. I still have to get 3. How do I get 3 if I have 3 numbers? By adding 1 plus 1 plus 1. It is still 3/5. Number 2. For number 2, you have a whole and you have a fraction. This is called a mixed number. So we go up to the top. It says a mixed number has a whole number part and a fraction part. So whole, it has a whole number part. Sorry, mixed number, whole number part, and a fraction. The model below shows the mixed number 3, 1/8. How can you break apart 3 and 1/8? Each whole can be shown as 8 equal parts. If you notice, the denominator says 8. So how can we show one whole? By having all 8s complete. So my whole will have 8 parts. So if I'm using all of them, that means 8/8. So one whole is the same thing as saying 8/8. But I have 3 wholes. So I'm going to write 1 whole plus 1 whole plus 1 whole. That equals 3 wholes plus the 1 out of the 8 to equal 3 out of 8. So if you go on number 2, I'm going to start with 1 3/4. How do you show one whole? Look at the denominator. The denominator is 4. So that means that the number at the top has to be the same because that makes one whole. But I'm still missing the 3/4. So how do you add 3/4? We would add 3/4. So I'm saying 4 out of 4 is the same thing as 1. If I add 3/4, that would make 1 3/4. What's another way we could show that? We could also say, for example, 6 out of 4. That would be 1 whole and 2 parts. So I would be missing 1/4. If you notice, if I put them together, that would be denominator 4. My numerator will be 6 plus 1, which is 7. That is an improper fraction, so I would change it to a mixed number. So how many times can the 4 go into 7? That is 1. The denominator stays the same. 7 minus 4 is 3. We still get the same fraction. Number 3, complete the following statement. Then draw a model to show that the statement is true. 7/8 equals blank plus blank. How can we break apart 7/8? Well, the denominator has to stay the same. I need to break apart the 7 into 2 numbers. What 2 numbers give me 7? 5 plus 2. Now that's not it. I could have said 4/8 plus 3/8 because 4 and 3 give me 7. I could have also said 6 and 1 because 6/8 plus 1/8 would give me 7/8. So notice that there's different ways to decompose the fractions. Number 4, Paul said that the sum of 1/10 plus 7/10 plus 4 out of 10 is the same as the sum of 5/10 plus 5/10 plus 2/10. Is he correct? Explain. So the very first thing we're going to do, we're going to make sure that we add all 3 together so that denominator is going to stay the same. 1 plus 7 is 8 plus 4 is 12. Now we're going to add the other set of fractions. The denominator will stay the same. 5 plus 5 is 10 plus 2 is 12. So do they have the same thing, the same sum? Yes, they do. The sums are the same. So the answer is yes, he is correct. In 5 through 8, write each fraction or mixed number as the sum of fractions in 2 different ways. So we need 2 different ways. So we're going to start with 4 out of 6. Remember that the denominator is the same. How can I break apart the 4? I could say 2 plus 2. Now the fraction's still the same, but they want me to decompose it in a different way, now using 3 fractions. So the denominator is the same. For the numerators, I need to get to 4. How can I get to 4? I could add 2 plus 1 plus 1. 2 plus 1 is 3, plus 1 is 4. Number 6. For number 6, denominator is 9. And my numerator is 8. What 2 numbers can I add will give me 8? We could say 4 plus 4. In the next fraction, the denominator, remember, is going to be the same. How can I add, or what 3 numbers can I add that will give me 8? I could say 6 plus 1 plus 1. You could have also said 5 plus 2 plus 1. They're both going to give you 8. For number 7, we have a mixed number. So we have a whole. So if you look at your denominator is 5. How do I make a whole? By putting 5 over 5. And then we need to add the 3/5. So 5 over 5 means 1 whole. Plus the 3/5 will be 1 whole and 3/5. If we go to the same fraction, how can we show that? We could do the whole, which would be 5 over 5. But I still need 3 over 5ths. So the denominator is 5. But how can I get to 3? I could add 2 plus 1. That would give me 3. For number 8, I have 2 wholes. Look at your denominator. Your denominator is 2. So that means that the number at the top will be the same. Now, if you notice, Ms. Garcia made a mistake because it said that we have 2 wholes. And 2 over 2 only means 1. So 2 wholes, I would need 2 over 2, that's 1 whole, plus the 2 over 2, that's 2 wholes. So 2 plus 2 is 4 over 4. So my 2 wholes, I can show them by writing 4 over 4. And then we need to add half so that it gives me 2 wholes and 1/2. We could also break it apart by saying 2 over 2, that's 1 whole, plus 2 over 2, that's 1 whole. So that makes a 2 wholes. So now I'm only missing the half. Go ahead and turn now to the next page. Number 9 says, a teacher wants to distribute a stack of notebook papers to 3 groups of students, A, B, and C. Each group does not have to get the same amount of paper. List 3 ways the teacher can distribute all of the paper to the 3 groups. So they want me to list 3 ways. So the total is 1 2/3. The teacher wants to share them. It says that they do not have to be shared, does not have to have the same amount of paper. So they don't have to be the same, but I am sharing with 3 groups. So that means that I'm going to have 3 fractions. How can we break apart 1 2/3 in 3 fractions? Well, let's start by looking at the 1 whole. The 1 whole, if you notice, my numerator is 3. So I could say 3 out of 3, that makes 1 whole. And then I'm going to be left with the 2/3. How can I share 2/3? Denominator will be the same. How do you break apart the 2? 1 plus 1. Now that's 1 way. They're asking us for 3 ways to share that. We could also look at it by saying 1 2/3. So if you notice, the denominator is 3. So that means that 3 out of 3 makes the 1 whole. So if I add the 1 whole plus the 2/3, how much paper would I have? 3 plus 2 is 5, and the denominator stays the same. So another way to say 1/2 and 2/3 is to say 5/3. So what's a different way that we can share 5/3? Remember, we have 3 groups, so we need 3 fractions. So the denominator is going to be the same. How can I break 5 apart? We can break it apart by saying 2 plus 2 plus 1. We could have also said 3 plus 1 plus 1 to make 5. Remember that the denominator is going to stay the same. So that's 3 different ways to show that fraction. Number 10 says Jacqueline ate 1/5 of a bag of popcorn. She then shared the rest with Enrique. The two of them finished eating the bag of popcorn. List 3 different ways she could have shared the remaining popcorn. Okay, so the bag, she ate 1/5. So the bag total is 5. So 1/2 would be 5/5. She ate 1/5. So I'm going to subtract because she ate the 1/5. How much popcorn is left? 5 minus 1 is 4. So there's 4/5 left of the popcorn. It says that she shared the rest with Enrique. So this is what she shared. This is the rest that she shared. The two of them finished eating the bag of popcorn. List 3 different ways she could have shared the remaining popcorn. So I'm looking at this fraction. 4/5. Sorry. What are 3 different ways we could break it apart? Well, we know that we had 2 people, so we're going to have 2 fractions. And we need 3 different ways. So I'm going to go ahead and do my fractions 3 different ways. How can we break 4/5 apart in 3 different ways? The denominator's 5. So they're all going to be 5. So how can we break the 4 apart? We can say 2 plus 2. Or we can say 3 plus 1. Or we could say maybe 1 plus 3. So those are 3 different ways of how we could break apart the 4/5, the remaining popcorn. Number 11, Miss Anderson showed her class how to write 1 3/8 in several different ways. Which of the following shows one way Miss Anderson could have decomposed 1 3/8? The very first thing we need to know is that this is a mixed number. So if you look at your answer choices, in order for us to have a mixed number, that means that we have to have an improper fraction. So let's look at A. Denominator is going to stay the same. 3 plus 1 is 4. Is this an improper fraction? Is your big brother on top of the little brother? No. So that means I'm not going to have any wholes. So that cannot be my answer. We go to B. The denominators will stay the same. 3 plus 4 is 7. Plus 6 is going to be 13. Notice that the big brother's on top of the little brother. So this means it could be an improper fraction. Or that it is an improper fraction. It could be a mixed number. Sorry. I'm going to do C. Denominator stays the same. 3 plus 3 is 6. Plus 3 is 9. Plus 2 is 11. Notice that that's also an improper fraction. So that could be my answer. And then I'm going to go ahead and go to D. Denominator stays the same. 10 plus 3 is 13. So if you notice, 2 of the answers gave me 13 out of 8. So let's go ahead and see which one would be 1 3/8 as a mixed number. So I'm going to do the first one, letter B. How many times can the 8 go into 13? That would be 1. 8 times 8 is 8. So the denominator will stay the same. Now we're going to subtract 13 minus 8. That would be 5. Is that my answer? No, it's not. Notice that this one was the same as D, so we can already eliminate both of them. But let me go ahead and prove letter C. How many times can the 8 go into 11? That would be 8 times 1. The denominator stays the same. 11 minus 8, that would be 3. Does that match the answer? Yes, it does. So my answer is C. Number 12. Decompose the fraction 7/10 into 3 fractions that all have a different numerator. So they want me to decompose it into 3 fractions. 1, 2, 3. And they all have to have a different numerator. So this one, the denominator will stay the same. What 3 numbers give me 7? I could say 4 plus 2 is 6 plus 1 is 7. Notice that the numerators are all different. Okay? Number 14. In a class of 16 students, 8 students are boys. Write 4 equivalent fractions that tell which part of the class is boys. Then write the fraction in simplest form. So in a class of 16, 8 students are boys. So let's write this as a fraction. There's 8 students. How many in all? 16. So 8 are boys. They want me to write 4 equivalent fractions that tell which part of the class is boys. So how can we break this apart in 4 different ways? 4 different ways. So I'm going to go ahead and do fraction plus fraction 4 different ways. 2 and 3. 1, 2 and 3 and 4. And the other one's not going to fit, so I'll do it over here on the side. 1, 2, 3, 4, 5, 6, 7, 8. So how can we show 8 out of 16 in 4 different ways? Denominator's always going to be the same for all of them because my total does not change. How can we break apart now the 8? What is 2 numbers that will give me 8? Could be 4 plus 4. Now let's break it into 3 numbers. I could say 3 plus 2 is 6 plus 2 is 8. How about 4 numbers? 2 plus 2 is 4 plus 2 is 6 plus 2 is 8. How about 8 numbers? 1, 2, 3, 4, 5, 6, 7, 8. Notice that all those different ways give me my total